All right, welcome to Unit 2. Unit 2 is all about properties, and to learn about properties, we actually need to learn a little bit about our periodic table. We're not going to go into a ton of depth, but there's some parts of the periodic table that you need to know, and there's some ways that the periodic table is set up that I need you to be aware of as well. So, first key question, what do chemists use to represent elements and compounds? Well, in the ancient times, alchemists, which were the ancient chemists, they used like actual symbols, like icons, in order to represent different elements in nature. Okay, they considered elements like water was an element, air was an element, and obviously we know that not to be true anymore because those are made up of different elements. But we'll get more into that later on. But now, today, we use something called a chemical symbol, and the chemical symbols are based on Latin names. And what we do is we use 1 or 2 letter abbreviations of those Latin names in order to represent our chemicals or our elements. Okay. The first letter is always capitalized, second letter is always lowercase. If the English and the Latin name are similar, then the letters make sense, like oxygen's an O and carbon's a C. But sometimes they don't match up, like natrium is the Latin word for sodium. So we use an Na even though sodium has no N or A in it. Okay, same with potassium being a K, and some of these other ones, gold's an Au, for example. So chemical symbols are abbreviations in the names. For what language? That would be Latin. Periodic table, okay, it's useful because it actually organizes the elements into patterns and properties, okay? So it arranges the elements in which the elements are separated into groups based on a set of repeating properties. The periodic table allows you to easily compare the properties of one element to another, because what that means is if it's on the left side of a periodic table, like over here, okay, then it's going to have very different properties from anything on the right. But when things are close, like cobalt and nickel here, well, that means they're going to have very similar properties. Okay. Now, if you look, we're broken down into columns here and rows. The columns are known as groups, or sometimes they're called families, like especially over here in the non-metal section. Okay, and you'll notice that there's letters and numbers at the top here of each of the columns or each of the groups. Okay, the letters, okay, represent where it's at, whether it's on the top section or the bottom section. Okay, so go ahead and we can start labeling this now. And then the numbers just tell us how far over they are. Now, we don't go past number 8. Okay, so it goes like this, 1A and 2A, but then we jump down, and when we go down, we go to the B's. So now it's 1A, 2A to 3B, 4B, 5B, 6B, 7B, 8B. But now we don't count past the number 8, so we go back to 1, and since we're still on the bottom, we still use a B. And then 2B, and then we climb our way back up, so we're back to the A's. 3A, 4A, 5A, 6A, 7A, and 8A. Basically what that means is if I cut out this section in the middle and then squeeze the left side and the right side together, it would just read 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Okay. Now there's some different groups that you need to know on the periodic table. The first group is in the first column, 1A. That would be the alkali metals. They react violently with water. In fact, if you took some sodium and dumped it into some water, you would get a pretty violent reaction. I wouldn't want to be anywhere near it when it happened. There's some very cool YouTube videos. In fact, in class, this link right here takes us to a YouTube video of a small little piece of sodium being placed into water, and you get some pretty cool flames and sparks and things from it. Alkaline earth metals are group 2A. Okay, they're the ones right next to it. They also react with water, but not as violently, which should make sense because now we're moving to the right, and the properties change just slightly as I move to the right. The transition metals are in the middle, okay, and then down at the bottom, as a part of the transition metals, are the inner transitions. They're the extra ones down here at the very bottom. Noble gases are on the far right-hand side of the periodic table, so they have opposite. They're very opposite of alkali metals. Okay, alkali metals you think of as being solid, they're going to be metallic, have magnetic properties, maybe, and things like that. Noble gases are going to have none of those, none of that stuff. Okay, noble gases, in fact, those are the things you see in neon lights, hence the name neon lights, because one of the noble gases is neon. But not every neon light has actual neon gas in it. Some of them have the other noble gases like argon, krypton. You can see the different colors that they create. You can see here a little YouTube video about that. Okay, halogens. Halogens are the next group over. They would be 7A. This group right here, when you think of halogens, you think of halogen bulbs, like fluorescent bulbs, which should make sense because the very first element in that group would be fluorine. Okay. Other thing, down here at the bottom, the inner transitions, you're going to need to know the lanthanides, which is the top row, and the actinides, which is the bottom row of those inner transitions. But they give you a little cheat sheet here at the beginning. 57 and 89 kind of tell you which group or what the name is. Sometimes 57 and 89 are found up here. Okay, that's fine too. So if groups and families are the columns, then periods are the rows. There are 7 periods, get hence the name periodic table. Okay. And then there's 3 classes of elements that you're going to need to know. Okay, the first one are the metals. Metals are usually good conductors of heat and electricity. They're usually solid at room temperature with the exception of mercury, Hg, right here. And they're usually found, I shouldn't say usually, they are found on the left side of the periodic table. Okay, so you can read a little bit about metals. Nonmetals are found on the right side of the periodic table. They have properties that are complete opposite of metals, so that means they don't conduct heat and electricity very well. And most of them are gases at room temperature, but not always. Okay, most of them are gases. And then if you'll notice, there's a big staircase here that separates the metals and the nonmetals. Well, anything that touches that staircase, you can see these green ones, and that would include the PO and the AL, even though they weren't colored green. Those are known as metalloids, and metalloids have characteristics of both metals and nonmetals. So we've answered our 3 key questions. Make sure you pause it here and you can actually answer those. Okay, we're going to skip our mystery there for now, and then I need you to do this. You should have a blank periodic table that came along with your notes. If you haven't, make sure you download that from the website, mrkubuske.wordpress.com right now. And then I need you to color in the metals, nonmetals, and metalloids. And remember, include AL and PO as metalloids. You need to highlight the staircase. And then I need you to outline all the different groups. And don't forget halogens, even though they weren't placed on here. Halogens, remember, had a green outline. Okay? And then please make sure that you label all the groups and periods. And then don't forget the letters and numbers at the top of your periodic table. Okay? Hope you learned something. We'll talk more about properties next time.